got there. So this was from a couple of days ago, back when they were down at the latitude of Rio, and this is where Mafre lost out dramatically. Now, the reason that for all those squiggles is basically, if we just pause here for a second, there's a cloud that ran over the fleet, essentially in this direction here. So you can see Dongfeng were able to divert and get up above it as it passed over. So we can see a few squiggles in their path, but they didn't really slow down. The boat that really got hammered here is Team Mafre. So the reason for that is because the clouds kind of slowed down and stayed here in this position. Now, I'll talk a lot later on in the show about how these clouds sort of outgas in all sorts of different directions, but basically the cloud interrupted the wind that's coming from this direction and basically shut them down. So they were left drifting and struggling. So let's have a look at what those clouds actually look like to give you some idea of what these sailors are dealing with out on the water. First up is this beautiful image from leg 6, so earlier in the race. This was sent in showing a very localized rain cloud, and so there's not much wind around Brunel and turn the tide on plastic here, but there will be plenty of wind underneath the cloud. Let's have another look at that with the next image here. This was sent in overnight by Brian Carlin, the OBR on board Team Axon Rebel. Now, to give a little bit of an education on how these clouds work, we'll just pause here. Basically, the way this all works is this is called a cumulus cloud up here, and so it works all with updraft. So it starts off with a localized hot zone. That creates a little bit of hot air. Hot air rises, as we all know, and so with this air rushing upwards like this, it leaves a vacuum down here. Now, what happens is that then sucks in air from all around it in order to replace that air. So you end up with these currents rushing along horizontally and then up into the system. Now, these massive clouds can climb up to 33,000 feet or 6 miles high, which goes from the troposphere all the way up to the stratosphere. So incredibly massive systems. All of that energy way up high means that all of that vapor can sometimes condense into droplets, which creates the clouds that you can see. Small droplets turn into big ones. That turns into rain. Now, as these droplets fall through the cloud, they build up a lot of inertia, a lot of energy. Now, as those droplets fall, it grabs the air molecules around them as well. So, what happens is you end up with these down currents. When the down currents hit the surface of the sea, they end up splaying out like this. Now, remember, the boats are currently sailing in 10, 11, 12, 13 knots of wind at the moment. These downdrafts can be incredibly violent, sometimes up to 30 or 40 knots of wind. And so that makes life really challenging. Today's subject is all about clouds, and I know that's a tricky subject, so I've cooked up something a little bit special to help explain exactly what's going on. This is a physical demonstration here in Race HQ, but just work with me a little bit. This is not Alicante, this is now the South Atlantic Ocean. There's a synoptic wind here blown by these 3 fans, and the sailors are sailing northwards on starboard on a reach in sort of 12, 13 knots of wind. They're standing there in the cockpit. Life is good, as you saw, sunny, beautiful day, shorts and t-shirts, awesome days sailing. However, there's something dark coming on the horizon. This industrial-sized fan is going to stand in for our squall. So we've got 10 to 15 knots of wind here. Potentially in the downdrafts, we've got 30 knots coming out of this cloud. Now, keep an eye on what's going to happen with these little telltales. At the moment, they're on a beam reach as the boat is sailing northwards, and the blue lines represent the initial position of the wind, right? Now, here comes the cloud. It's been blown across the boat by the synoptic wind, and as it approaches, well, you get a little bit of wetness coming out of the cloud, but you see this massive wind shift. So the wind goes up, big increase in strength, and also a 45-degree wind shift. So if the boat is on a reach, they need to furl up that big masthead code 0 and switch to a jib and start sailing upwind to deal with that 45-degree wind shift. But as it approaches and rolls over the boat, you can see that we're now on a 90-degree wind shift. So that means that the boat is going to have to bear away, and this is what explains all of those squiggles that we've been seeing in the tracker over the last couple of days. As it rolls over the fleet like this, we go from a 90-degree wind shift to 100, 110, 130-degree wind shift. So we can see that the synoptic wind over there is completely dominated by the localized wind coming from the cloud. So that means we've got a tack on the boat. They're now sailing on port potentially, but the cloud is still blown by the synoptic winds and is slowly moving away. Now, this creates a tricky period of transition, because I want you to keep your eye on the winds here versus the winds here. Because as the cloud blows away, you can see that the synoptic wind starts to fill in again here. So we've got wind coming from this side, on this side of the table, and we've got wind coming from this side, on this side of the table. In the middle, we've got all of this turbulent flow, and you can't sail in winds that are fighting each other. There's basically nothing left in the middle. And this explains the massive losses like that we've seen from Mafre, for example. If you've got a big cloud that slows down and fights the gradient synoptic wind for a long time, there can be literally nothing in the middle at all. So you need to wait until that cloud moves away completely, allowing the wind flow from the gradient to fill back in, and then you can continue sailing on your way north, licking your wounds and waiting for it all to happen again. Anyway, now I hope you understand the sort of the physical demonstration of what actually happens. Let's hear again from TJ as to what life is like on the water when this actually happens. Now,